Hey everyone, I'm Zach. Today we're covering what AI actually is, tracing a straight line from Turing all the way to generative AI. AI Basics, Episode 1, let's go. Let me first explain what this AI Basics series is. In 10 episodes, we'll cover the history, mechanics, applications, and limits of AI, no equations required at all. Whether you're a programmer or not doesn't matter. If you've seen AI in the news and thought, I roughly get that it's impressive, but what actually is it? This series is exactly for you. The goal for episode 1 is to get the full picture of what AI is. From Turing's single question in 1950 to the explosive growth of ChatGPT, we're connecting 70 years of history in one straight line. Here's a number I want you to hold on to, 2 months. That's how long it took ChatGPT to reach 100 million monthly active users. Compare that, Instagram took 2.5 years. Netflix took 3.5 years. The smartphone took 7 years. So what changed? Why was that possible? In the next 10 minutes, I'm going to show you exactly how we got here. We'll trace AI's history from a single question posed in 1950 all the way to the models reshaping everything right now. No jargon walls, no math, just the through line. Let's go. Let's start with a clear definition. The most important sentence of today: AI is a system that learns patterns from large amounts of data to imitate, assist, or extend human cognitive tasks. 2 key ideas. First, it learns its own rules. Second, it handles tasks we'd call intellectual. A calculator isn't AI, it follows rules a human wrote, and without those rules, it does nothing. But a spam filter that learns which emails are junk by studying thousands of examples? That's AI. A model that recognizes faces in photos? AI. Because in each case, given data, it finds the pattern itself. Let me take you back to where it all started, a question written down in 1950 that nobody has fully answered since. The whole story of artificial intelligence kicks off with one paper by Alan Turing, Computing Machinery and Intelligence. It opens with a deceptively simple question: can machines think? To tackle this, Turing came up with the imitation game, a thought experiment where a human judge has a text conversation with both a human and a computer, without knowing which is which. If the judge can't reliably tell them apart, Turing argued, we might as well say the machine has intelligence. That became the Turing test. In 1956, at Dartmouth College, the term artificial intelligence was officially coined. Researchers back then were genuinely optimistic. Give us 20 years and we'll build a machine with human-level intelligence, they said. Reality was more stubborn. The field kept hitting walls in computing power and algorithm design. Twice, in the 1970s and again in the 1980s, research funding dried up almost completely. These became known as AI winters. AI died twice. But one fundamental shift in thinking changed everything. The turning point came in the 1980s. Instead of programming explicit rules, if A, do B, researchers asked a completely different question: what if machines could learn the rules themselves from data? That's machine learning, and that shift was everything. The classic example is spam detection. Instead of writing a rule that blocks emails with the word free, you show the model thousands of labeled spam and non-spam emails, and it figures out the pattern on its own. Think about what that means. A machine that teaches itself to make judgments, without a human writing the rules. Let's look at where machine learning shows up in your daily life. First, recommendation systems. When YouTube or Netflix suggests your next video, that's AI analyzing your viewing history against patterns from millions of other users, predicting what you'll want to see. Second, fraud detection. The system that flags suspicious credit card activity in real time is machine learning. It spots when your pattern suddenly breaks, like a transaction in a foreign country when you've never left home. Third, medical imaging. AI trained on millions of X-rays and MRI scans can now detect anomalies faster and sometimes more accurately than human radiologists. In every case, no human wrote the rule. The system learned it from data. In the 2010s, machine learning took another huge leap: deep learning. Deep learning uses artificial neural networks, layers of computational nodes loosely inspired by how neurons in the brain connect, stacked dozens or even hundreds of layers deep. The watershed moment was 2012. A team from the University of Toronto entered the ImageNet image recognition competition using a deep neural network. They didn't just win, they crushed it, cutting the error rate nearly in half. AI research exploded after that. Facial recognition, voice assistance, real-time translation, all of it runs on deep learning. In 2017, a team at Google published a paper introducing the transformer architecture. Its key innovation was self-attention, a mechanism that allows the model to track relationships between words across an entire sentence, not just neighboring ones. That enabled language understanding at a completely new scale. OpenAI built on the transformer to develop the GPT series. When ChatGPT launched in November 2022, it reached 100 million monthly active users in just 2 months. Here's what makes generative AI genuinely different. Search engines retrieve information, they've done that for decades. Generative AI creates new content. Text, code, images, music, creative work that used to require a human. How does it work? At its core, a large language model trains on enormous amounts of text and solves one deceptively simple task: predict the next word. Do that billions of times across hundreds of billions of parameters, and something emerges that looks, and in many ways behaves, like understanding. But today's AI has real limits, and being clear about them matters. First, hallucination. ChatGPT will sometimes state something confidently and completely wrong. Why? Because it's not retrieving facts, it's predicting the statistically likely next word. Sometimes that prediction is wrong, and the model has no way to flag its own uncertainty. Second, bias. If the training data reflects historical patterns of discrimination, the model learns those patterns too. There have been real cases of AI hiring systems that disadvantaged certain groups, because the data they trained on did. Third, no memory and no genuine understanding. The model doesn't remember your last conversation. It doesn't understand, it pattern matches. And that brings us back to Turing's original question. Today's AI might pass the Turing test in some contexts. But is it actually thinking? That question, the one Turing asked in 1950, still doesn't have a clean answer. So, back to where we started. Why did ChatGPT reach 100 million users in 2 months? Because 70 years of accumulated research, machine learning, deep learning, the transformer, all came together, wrapped in an interface anyone could use, a chat window. Our working definition of AI, a system that learns patterns from large amounts of data to imitate, assist, or extend human cognitive tasks. But keep this in mind. However impressive today's AI systems are, they don't have consciousness or genuine understanding. AI is a tool. An extraordinarily powerful one. How we use it is a question only humans can answer. Neural networks kept coming up today, but I haven't actually explained how they work yet. In episode 2, that's exactly what we're doing. How does a layered computational structure actually learn? What's happening inside the model? Once you get it, the way you see AI will change permanently. I promise it's worth sticking around for. Subscribe so you don't miss the next one. See you then. Don't miss the next episode. Subscribe to the channel and hit the bell.